So here's a review of what you did on Friday. This one. Okay, so if we look at the first two problems, what you're doing is graphing a parent function and then graphing a transformation. And the transformations in number one are all the same. You graph the graph, and then you graph the negative version of the graph. So you see the transformation right here. It says negative f of x. And one thing you might want to remember, if we had f of x equals x squared, that's exactly the same thing as y equals x squared. Someday that's going to go away. So y and f of x are the same thing. So if you look at that function, or that transformation, negative f of x, just think of it as negative y. If you took a graph and you changed all of its y values, you changed their signs. If all the positive y's became negative y's and negative y's became positive y's, what would that do to the graph? Flip it across the x-axis. So the first graph might look like that, and the second graph would look like that. So x-axis. That's by making the outside negative. Anything that happens to the outside will change the y values. Anything that happens inside will change the x values. If you can remember that, you don't really need to memorize all the transformations. You can just think them through when you see them. So on number 2, f of negative x. So that means we change the sign of all the x values. So if I make the negative x as positive and the positive x as negative, what's that going to do to the graph? Well, when I changed the y value signs, it flipped it across the x-axis. If I change the x value signs, it's going to flip it across the y-axis. So this is a y-axis reflection. So both of these are reflections. So reflect across the x or reflect across the y. Okay? If you look down at number 3, it says f of x plus c. Is that going to alter the x values or the y values? Well, am I adding to x or am I adding to f of x? I'm adding to the f of x, and f of x is just y. So if I add to the outside, the graph goes up. If I subtract from the outside, the graph goes down. That's pretty straightforward. So if c is positive, then it's going to shift up. If c is negative, then it's going to shift down. Okay, and this is the only tricky part. Number 4. So here we have f of x plus or minus c. Now I'm changing the x values. So if I add to the inside, it's either going to go left or it's going to go right. But the trick here is it always goes in the opposite direction. So if I took x squared and I changed it to the square of x plus 2, which way is that going to move? Left 2. This is the only one that goes backwards. If you add to the inside, then you move to the left. Well, why is that? Well, it has something to do with the roots. What is the root of that? What makes that 0? 0. What makes that 0? Negative 2. So that root was shifted to the left 2. By adding 2, we shift to the left 2. So if c is positive, then it's translated to the left. And if c is negative, then it's translated to the right. All right, number 5. 5 and 6 are a little bit confusing. We're not going to get terribly into detail. You can see the first one is c times f of x. So if I multiply the y values by c, whatever c is, and then number 6 is you multiply the x's by c. Well, this is a little less obvious, but anytime you multiply where c is bigger than 1, and we actually say absolute value of c, so like 3 or negative 3 doesn't really matter. Okay, the negative is going to be a reflection, and then the 3 itself tells you whether it's going to stretch or shrink. You got the giggles. You don't have the giggles. I'm all confused. Okay. So this says if the absolute value of c is bigger than 1, is that going to stretch it vertically or is it going to compress it vertically? If I times the y values by 3, is that going to stretch it or is it going to compress it? Stretch it. Is it going to change the x's or the y's? The y values. All right? If c is between 0 and 1, so a fraction like 1/2 or 1/3, then is that going to stretch it or compress it? Compress it. Is it going to change the x's or the y's? The y values. Because it's multiplied outside. So the other one, compress, stretch, and they're both x's. But we're not really going to deal too much with that one because it's harder than it looks. So when we multiply, we'll just multiply on the outside. Or if it's multiplied on the inside, we're going to pretend that it does the same thing as it does on the outside. Because it's kind of complicated and we don't really care. All right. So look at the paper that says pre-calculus number 1. I just answered those. Compression, stretch and compression in both x's. No, the x values and y values are different. That's the only difference. The top 2 were y's and the bottom 2 are x's. But the stretch and compression work the same way. Okay. Well, let's do a really quick review. So let's say I had some function f of x. It doesn't matter what it looks like. Okay? If you take a parent function and you add 3 to it, what direction is it going to move? Well, remember, f of x is y. So if I take the y values and I add 3 to it, it goes up. Okay? What about if I make the x negative? Well, that's changing the x's. If I flip the x, so if I take all the positive x's and I make them negative, they're going to land over here. If I take all the negative x's and turn them positive, it's going to land over there. What effect is that going to have? Flip across the y-axis. Okay? All right? What about, oh, let's unlock that. What about adding 3 on the inside? Well, I'm changing the x's. So it's either left or right. But inside, it's always backwards, left. All right? What if I times by 3 on the outside? The y's get bigger, so it's going to stretch vertically. And multiplying by 3 on the inside, we're just going to say it stretches 3 times vertically. It's a little more complicated than that, but whatever. A lot of times it doesn't even come up. Okay? What if I make the outside negative? So the f of x is negative, which means the y values are negative, so all the positive y's become negative and negative becomes positive, so it flips across the x-axis. What if I subtract 2 on the end? So I take my y values, pull them down 2 units. Okay? What if I subtract 2 on the inside? Goes to the right 2 units. Okay? What if I times it by negative 2, subtract 4, and add 1? So what does that one do? Flip across the x. What does this do? Vertical stretch. What does that one do? Right 4. What does this one do? Up 1. Good. So, if I divide by 4, add 1, and subtract 3, what is that going to do? 4 times wider, move to the left 1, and down 3. Now, what order do I do those in? You start with the x. You start with the input. So if we focus on the x, left 1, 4 times thinner, down 3. Whenever there's a reflection and a translation, you have to do them in the right order or you might end up in the wrong place. Okay? When in doubt, though, just plug it in your calculator and it will give it to you. You need to know what the function is, right? So if the function was the square root of x, then the transformed function would be the square root of x plus 1 all over 4 and then minus 3 to the outside. Okay, so if you look at the Pre-Calculus Unit 1 worksheet, up where it says day 1, which is funny because it's going to take us just a minute to finish that, you have 2 sides. You have a matching on the left and a matching on the right. So go ahead and do the matching on the left and then do the matching on the right. So number 1, what's the transformation? 7 to the right. Number 2, 7 units down. And translation just means you're dragging it back and forth. You're not changing how the graph looks, you just change its position. Number 3, vertical stretch. It's going to stretch vertically. Number 4, left 7. Number 5, up 7. Number 6, shrink it. Okay? Going over to the next one. Number 7, vertical stretch. Number 8, reflect across the x. Because all the y values are going to change sign, so you reflect across the x. Number 9, reflection across the y. Number 10, left 7, and number 11 is up 7. Up 4, whatever. Okay, part 3. Match each equation with a sketch of its graph. So you have 8 equations, and they're all based on the parent function x squared. They've just been transformed somehow. So you need to match each equation with the given graph. Go ahead and do that. So that part 3 is pretty easy. Are there any you want to talk about? Okay, we'll just do a couple. So number 12, what's the transformation? Up 2. Okay, let's skip to 15. What's the transformation on 15? 2 to the right. Because it's inside, the x's are changing, and the inside always works backwards, so it says minus 2, so you move to the right 2. What about number 18? Right 2, up 1. Okay. For these last 5 problems, it's just a domain and range. Number 20 is just 5 dots, and number 21 is a horizontal line that starts at -3 and stops at 2 or 3, I don't know. So number 20 is just 5 dots. What are the x values of that graph? -3, -2, 0, 1, and 5. What are the y values? Just -1. That is the entire domain and the entire range. It's not an interval, it's just a set of numbers. Okay? Number 21, what are the x values? From -3 until +3, and how do we know if we include them or not? If there's an open circle, we know it's a parenthesis, but here they don't tell us. So if it's unknown, it always counts. And what are the y values? -3 again. Okay, so you have domain and range on those last few. And then, hopefully I kept it. On the second worksheet, here are the parent functions. Now I want you to try to graph these without a calculator. So you just take those parent functions and you do whatever transformation is listed. So for example, if I had 2 square root of x minus 1 plus 4, I would take this square root of x graph. So I take this graph here. I'd move it right 1 and up 4, and I'd make it twice as tall, so it would look like that. Yeah, the 2 in front makes it twice as tall. So let me get rid of that. So here are all your parent functions. So for the second worksheet, so the first one says x squared minus 1. So you take that first function, and which way are you going to shift it? Down 1 unit.